You are about to be fixed. Physics Fixed. Better than real. Where each brief episode brings insight you've never had before by smashing through conventional barriers. It's Occam's razor in the hands of Jack the Ripper. It's round 2 with Spin 1/2 in Riding a Bicycle. Once you learn, you'll never forget how. In episode 7, we use the Euclidean lens of interval time coordinates to literally lift the veil of space, revealing Spin 1/2 as chronaxial, that is, spin about a fermion's timeline. This quantum spin projects equal components in every spatial direction, exactly as observed. But other Spin 1/2 properties await explanation. For example, its peculiar 720-degree rotation. A classical angle alpha defines a two-plane for which full rotation entails 360 degrees, or 2 pi radians, the length of a circumference expressed as the number of its radii. A circular arc of any size can be expressed in degrees or radians. Its central axis is perpendicular to the plane of rotation. A complete chronaxial rotation about time occurs one dimension up in an XYZ 3-plane. It thus subtends something different than an arc or an angle. Fortunately, this isn't a mystery. Rotation in a 3-plane describes a solid angle omega enclosed by a spherical area. The area of a full sphere is 4 pi r squared, or 4 pi steradians. Steradian means square radian, or r squared. In a 3-plane, the same sphere appears as a circle, but still entails 4 pi steradians. Like any dimension, as time supports translation, it must also support rotation as an axis. But since time is inherently unidirectional, it can't support the back-and-forth oscillation required in the 3-plane. So, from a 4D perspective, a full solid angular rotation always occurs in an XYZ 3-plane. Classical spin around a spatial axis develops helically with time, not around it. The reason you can't rotate around time is that you're a sizable system of particles. At any non-zero radius, chronaxial spin, being essentially instantaneous, would violate universal speed limit c. Fundamental particles have zero radius, thus no such restriction. So what's the 1/2 about Spin 1/2? Frankly, this oxymoron is a doozy of a mistake that's about to be fixed. There's no such thing as half a quantum, since a quantum is defined as the minimum amount of any physical entity involved in an interaction. Spin 1/2 implies such a halving, but actually results from incorrect reduction of the Planck constant. Of note, in applications where it is natural to use the angular frequency in terms of radians per second, it is often useful to absorb a factor of 2 pi into the Planck constant, called the reduced Planck constant, equal to the Planck constant h divided by 2 pi, and denoted h bar. That's fine for classical rotation in a 2-plane. Trouble is, in vehemently denying Spin 1/2 is classical rotation, physicists have no basis to presume 2 pi radians is the correct denominator. And since chronaxial spin occurs in a 3-plane, its solid angular range of 4 pi steradians is a better choice to reduce a quantum of fermion spin. So it should be no surprise that h bar over 2 is measured, since that equals h over 4 pi, which no longer implies half a quantum. Getting that fixed solves yet another important mystery. Quantum electrodynamics rightly boasts astounding precision for the electron magnetic moment, but mysteriously remains off by a factor of 2. One famous triumph is the accurate prediction of the electron g-factor. The magnetic moment of an electron is approximately twice what it should be in classical mechanics. The factor of 2, g sub s, implies the electron appears to be twice as effective in producing a magnetic moment as the corresponding classical charged body. The intrinsic spin magnetic moment for an electron, U sub s, is given by this equation, where s is the electron spin angular momentum and U sub b the Bohr magneton. Both those terms incorporate h bar over 2, which in that form is fully reduced to h over 4 pi. However, in the denominator of U sub s, h bar is only half reduced, as h over 2 pi. If this h had instead been reduced by the solid angular range of 4 pi, it would be equivalent to having a factor of 2 in the numerator. Thus, g sub s would not mysteriously need to be twice that of the classical g factor. G sub s was never more than an unjustified fudge factor. Now, recognizing spin 1/2 as chronaxial with a solid angular range, physics really can boast the most precise agreement ever between theory and measurement. Congratulations! Now you're even more of a half-wit. We're not finished yet. What the is a probability amplitude? You'll find out in probable cause next time on Phyxed. I'll see you there, if you dare. Haha. Check out some nice conventional descriptions of spin 1/2 in the video links below.